Hi all. Today we need to find the expansions of the sine and cosine of angle in a series of ascending powers of the angle. Last class we have seen the expansions of sine n of angle, cos n of angle in terms of or the powers of cos and sine. So now we need to expand cos and sine in terms of the angle. Okay. So last day we have proved uh, cos n theta equal to cos raised to n theta minus n times n minus 1 divided by 1 in times 2 cos raised to n minus 2 theta sine square theta plus n into n minus 1 into n minus 2 into n minus 3 divided by 1, 2, 3 times 4 cos raised to n minus 4 theta sine raised to 4 theta minus etc. Of course, this has a last term. The sum in the right hand side contains only n plus 1 terms. So this must terminate. So this can be now we this equation is true for every n for every positive integer and every real value theta. Okay, so if we are given let alpha be a real number, we put uh, theta is equal to alpha by n, or n theta is equal to alpha. Okay, so we can replace any real number here for theta. So we replace this theta by alpha by n for any n. You can replace any n. Okay, so we can let this n tends to infinity as well. So for any fixed real number alpha, we need to define theta as alpha by n for any n. Then this as this n tends to infinity, the number of terms in the right hand side tends to infinity rather than n plus 1 terms. Clear? So we need to get an expression of cosine theta in terms of theta. We need to let this n tend to infinity. So what happened left side n theta is since n theta is alpha, we have some limit here, some kind of limit here, as theta as n tends to infinity, if and only if theta tends to 0. Yeah, this is an equivalent condition. So the LHS will be cos n theta is alpha here. That is equal to, now we have cos raised to n theta. All right, that time as such. Then we have minus. I want to replace all the n by all the terms in the right hand side in terms of theta. So theta and alpha. So this n can be written as alpha by theta into alpha by theta minus 1 divided by 1 times 2 cos raised to n minus 2. Here we have theta itself, sine square theta, plus here we have alpha by theta, alpha by theta minus 1, alpha by theta minus 2, alpha by theta minus 3, whole divided by 1 into 2 into 3 into 4. This is cos n minus 4 theta sine raised to 4 theta minus etc. So this right hand will also terminate. Clear? So this will be cos raised to n theta minus, I simplify this one. I write it as alpha into alpha minus theta divided by 1 times 2 cos and minus 2 theta. Right here we have a theta square in the denominator, so I place that theta square along with the sine square theta by theta square. I need to take a limit as theta tends to 0, so this will tends to 1 because theta limit theta tends to 0, sine theta by theta is 1, so we can replace this by 1 in the next step. So this will be alpha minus theta, alpha minus 2 theta, alpha minus 3 theta. The denominator we have theta raised to 4. I'll write that theta raised to 4 along with the sine raised to 4 theta. So this will be 1 times 2, 3, 4. Right, this is minus 4 theta sine raised to 4 theta by theta raised to 4 minus etc. Okay, now take limit n tends to infinity. Then what happens? As n tends to infinity, that is equivalent to theta tends to 0, hence sine theta by theta tends to 1 and cos theta tends to again 1. We have this much limit. So there is no change in the left hand side. So there is only independency for this theta and n. So I write this is cos alpha is equal to, as theta tends to 0, this cos or n tends to infinity, we have theta tends to 0. As a consequence, we have these two limits, so this can be written as 1, and this will be, as theta tends to 0, we have this is alpha squared by factorial 2 cos, again this is 1, sorry, this is 1, and this is also 1, plus we have alpha. Again, from this we can get alpha. All these terms will change to alpha. So this will be alpha raised to 4 divided by factorial 4. This will be again 1. Next term will be 1 minus etc. So we have cos alpha can be written as, of course, this right hand side must have infinitely many times. So 1 minus alpha squared by factorial 2 plus alpha raised to 4 by factorial 4 minus etc. So this is what we need to get, the expansion of cos alpha in terms of alpha. That is the title here, expansion of the sine and cosine of an angle in series of ascending powers of the angle. So this is cos alpha and this is the series in the ascending powers of the angle alpha. Okay, now we can find the expansion of sine alpha in terms of alpha or ascending powers of alpha. So for the sine, we already proved that sine n theta equal to n times cos minus 1 theta sine theta minus n times n minus 1 times n minus 2 1 times 2 times 3 cos raised to n minus 3 theta sine to 3 theta plus etc. So we perform the same thing as we done before. So this is put theta is equal to alpha by n. Let alpha is a real number. Then we have all the limits from this equation as n tends to infinity. Without changing alpha, we can let this theta tends to 0 and vice versa. Then what is the substitution here? Yeah, we have n theta is equal to alpha. Then sine alpha is equal to, I'll write this n as, what is n here? Alpha by theta cos n minus 1 theta sin theta minus alpha by theta minus 1 alpha by theta minus 3 divided by 1 times 2 times 3 cos n minus 3 theta sin 3 theta plus etc. Then so we can get uh, sin alpha equal to of course by taking limit as theta tends to 0 we can place this theta under this sin theta, then sin theta by theta will go to 1, then the remaining is this tends to again 1, then this will be alpha and minus. From this you can get alpha minus theta, alpha minus 3 theta. As theta tends to 0, this term will be alpha into alpha into alpha. The theta cube can be placed here, then that will go to 1. This is also go to 1. So we have alpha minus alpha cube by factorial 3. The next term will be alpha raised to 5 by factorial 5 minus etc. So this is the expansion of sine alpha in terms of the ascending powers of alpha. Okay, next we will see the expansion of tan theta in the series in the ascending powers of theta. So for next we have to discuss tan theta. Okay, we know that tan theta is equal to sine theta by cos theta, where we have proved that sine theta is equal to theta minus theta cube by 3 factorial plus theta raised to 5 by factorial 5 minus etc. And cos theta is equal to 1 minus theta squared by factorial 2 plus theta raised to 4 by factorial 4 minus. So in order to expand this tan theta, we substitute the expansions of sine and cos uh, in this equation. So we have this would be theta minus theta cube by factorial 3 plus theta raised to 5 by factorial 5 minus etc. Divided by 1 minus theta square by 2 factorial plus theta raised to 4 by factorial 4 minus etc. Yeah. So now this is a quotient, but we write this is equal to theta minus theta cube by factorial 3 plus theta raised to 5 by factorial 5 minus etc. times I will write this is equal to 1 minus theta squared by factorial 2 theta raised to 4 by factorial 4 minus etc. raised to minus 1. Okay, now that is equal to theta minus theta cube by factorial 3 plus theta raised to 5 by factorial 5 minus etc. into, so this is of the form 1 minus something whole raised to minus 1. So I'll write this is equal to 1 minus of theta square by factorial 2 minus theta raised to 4 by factorial 4 plus etc. raised to minus 1. Okay, but we know that there is an expansion 1 minus x whole raised to minus 1, that is equal to 1 plus x square plus so on. So we have to compare this term with 1 minus x whole raised to minus 1. Here this expansion is valid only when mod x less than 1. So we need to check modulus of this quantity is less than 1. So I left it as an exercise. So you must verify that the modulus of this is less than 1. Okay? So this is equal to, we have theta minus theta cube by 3 factorial is 6 plus theta raised to 5 by 120, 5 factorial is 120 minus etc. times this. What is this? This is equal to 1 minus. Instead of x, we have this term, so this is x theta squared by 2 factorial is 2 minus theta raised to, this is bracket, theta raised to 4 by 24 plus etc. Instead of x, we have this term. Next term will be square of this. Theta squared by 2, theta raised to 4 by 24 plus etc. square plus etc. So this will be equal to theta minus theta cube by 6 plus theta raised to 5 by 120 minus etc. into, so this can be considered, this can be simplified as 1 plus theta square by 2, okay, then minus theta raised to 4 by 24 etc. plus, here we have theta raised to 4 by 4 etc. Okay, this is from this equation. Sorry, here we have plus sign here. This is 1 plus x square, etc. So 1 is here, and I write this term itself here. And from this, I can get the least degree term is theta raised to 4 by 4. That is the square of the first term. Rest of the terms has the power greater than or equal to 5, greater than or equal to 4. So we neglect those terms. We try to write first 3 or 4 terms of the series. So we neglect the higher power terms. So I write this bracket as 1 plus theta square by 2 minus theta raised to 4 by 24, etc. Plus from this you can get a term containing the degree raised theta raised to 4. So this can be written as theta minus theta cube by 6 plus theta raised to 5 by 120 into minus etc. into 1 plus theta square by 2 plus 5 by 24 theta raised to 4. I simplify these two. I multiply 6 in the numerator and denominator. So then we can get, this is 6 times theta raised to 4. Here we have minus theta raised to 4. So that is 5 times theta raised to 4. Denominator as 24. Okay. So plus etc. Then this will be equal to theta cube, sorry, theta plus theta cube by 3 plus 2 by 15 times theta raised to 5 and so on. So the rest of the terms has the a degree more than 5. So, I'll write this, this implies tan theta. Tan theta can be written as the ascending powers of theta as theta plus theta cube by 3 plus 2 by 15 times theta raised to 5 plus etc. Okay. So this is the expansion of tan theta in the ascending powers of theta. Thank you.